Well, hello everybody. Welcome back to the Bison Workshop. I'm Bob, and we're having our Trump coffee this evening. And I've done went and did it. It just finally got to the better of me, and I decided that it's time for me to do something about it. The title probably gives it away, but we're going to give this mill a motor overhaul. Basically, all electronics are going to be overhauled completely. What I'm doing right now is checking to see if it's possible for me to be able to take a treadmill motor that's a 2.5 horsepower, I think. This originally came with an AC motor, runs off of 110 volt. It works fine. There's one aspect that I would like to change, and I'd like to make it reverse, forward and reverse. I tried that at one time, thinking that these were DC motors, and I was wiring it like a DC motor, and that's why every time I turned on my reverse, it would blow my fuse. So I didn't know it was an AC motor until I took the cover off the other day and looked at it. But what I've got here is and I always have these in the wrong orientation when I want to read them, and these things ain't light. This is a 1.3 horsepower continuous duty, 95 volts. Alright, so, but it says it's a 2.25 horsepower, 2.25. But we're worried about the continuous. So this one's actually the smallest one I have as far as diameter goes. So then I've got this other one that is also a 2.5, but it doesn't tell me what the continuous duty is on it. However, it is a 130 volt DC rather than a 95 volt. So I don't know which one I want to use more. Let's see. But what I'm doing is comparing, and I'll show you here. So what we have here is the original motor that came out, and it's a 110 volt, and it's going in that direction. We don't really care about direction because we're going to change the direction anyway. So what I need to do is modify one of these motors. I haven't decided which one I'm going to use yet. I actually think that the other one, I just want to make sure that the motor is the same size or smaller than the one that's on it. So I could use either one of them. So basically what I have to do is make this match the distance between the top of this gear and these standoffs where it mounts to the top of the motor. Those are the two critical measurements that we need to do. So we need to mimic this over here. But because the treadmill motor has this step up right here, you have that step up before it comes to the flat where it ends, where the shaft is. So I don't think these are hardened shafts. So we're probably going to try to take and put this in the lathe. We got to disassemble the motor. Then I got to bring this measurement down to the same size as this. That's why I want to use the smallest diameter motor that I can get, because I'm going to have some space to be able to mount my plate. So I'm thinking about taking one of these plates as soon as I get my eye on one of them. And I may have to double up on them. I don't know. that's more than a 1/4 inch. So I'm probably going to have to double up on this and make 2 plates identical to each other, and mount that to this plate that is the exact same size as this. Then we got to make sure that we have a way to mount this to this. Yes, there is a way to mount this to it. These bolts go all the way through. This is the head of it. This is the tail of it. We got plenty of room that we can put, be close, but we can get 2 plates on there. We really only need about 1 1/2 or 1 2/3. But I'm not gonna I'm not gonna shave one of these down. So it's possible if I had the aluminum, I could just make one. But this is the biggest piece of aluminum that I can use, and it's what I have here. So it's possible that I could just take and put shims in it too. Just make 1 plate, put a shim in it like these right here are, and do it that way. So what we have to do, we have to modify it so that this gear will fit this shaft. We got lucky. It's not splined. It's keyed. I can put a keyway in this, no problem. I can turn this down to the same size as this shaft and put a keyway in it. And I've got my motor, DC motor. So this is going to be set up in a way that I could take and use either one of these motors if I wanted to. I could just switch them if I needed to. Of course, I'd have to change it from AC to DC to AC if I was to go back, but that probably ain't never going to happen. But this is a good motor. It will be used for something one day. It's got nice mounts on it. It's flat surface. It's got a shaft on it that can be used for a set screw on it. But anyway, then we have another problem, the cooling. When I make this plate, I'm going to have to make some kind of a vent so that these can cool, because I plan to, at least this is my thinking right now, it doesn't mean that's what's going to happen, but in order to cool this, I was thinking that I could take one of these 12-volt fans, because I do have 12-volt at the mill, and make a 3D print a plate that goes on top of this, or like a housing or something, that this will mount on the top of it, and this will pull air through. So it would probably be better to just make standoffs like these, just little round thick washers, however thick it needs to be, to get this plate. Let's get a smaller plate to put up there. That thing's getting too heavy. So we could take and put that there and make our washers to go in there, and then we'll drill our holes where these 2 studs here goes through, all the way through, and countersink them, and we'll mount this plate with these bolts. So that will make this permanent to this. But before we can do that, I've got to get it at least down to as wide as this. So this will have to be turned down, and the good part about this motor is I made a bracket for it. Let me show you that. If I orient this then in the right direction to where these bolts are facing backwards, or to the left, where I can mount something to it, like maybe a DRO later on down the road, I could take and put this, can't put it forward, but I can put it off to the side or out the back and just mount my power supply on it. I could do that. get that power supply up, because I need to move that power supply because I'm going to put an H-beam in there one day and stiffen that frickin' mill up. But anyway, so we're going to have to disassemble this motor, but I got to get measurements first, I think. There has to be a stop on this, so I need to figure out how deep this needs to go before it stops. I don't know if I can turn it all the way up to the bearing. I don't know. We're going to need at least, it looks like there's a lot of play there, so I guess tolerance ain't a thing on this. So it's got that much play in it right there. So it's probably so for alignment issues, because this is a tapered gear. So basically, I think what I want to do is copy from this point down in here, this flat, to the bottom of the gear. And then we'll do the same thing here to the bottom of the gear. So I could probably, hell, I might even have one here, sleeve or something that's that size, that we can kind of mimic what we're after. Well, damn, that's not 5/8. Maybe it's this one. All right. So basically what we would do is measure from, actually no, we need to measure from here to get that distance. Wherever your mounting surface is going to be, that's where you're going to have to measure from. So we'll have to get the distance between here, which is probably pretty close to 1/4 inch, just a little bit over, probably about 7-8 millimeters. So we just want to make sure that, I think 1/4 inch would probably work just fine. So we need this to be 1/4 inch from the finished surface, because we got to do the surface first. So I guess the first thing I need to do is get this thing taken apart and check this up in the lathe. I'm hoping this is welded real good. I don't know how they weld those things. Looks to me like there's a spot weld there, something, or alignment tool or something. It might even actually come off. I might just be able to stick this in there. So let's take this thing apart. And if worse comes to worse, I got another motor if I screw this one up. I got 3 of them, 3 of these. This one's the smallest one. So let me take that apart. Well, 3/8. Watch it be 10 millimeter. Yep. And we're not going to use these blue wires. We're just going to worry about the red and the black. I'm going to have a fuse in it anyway, so it doesn't really matter. All right. Brushes seem to be in good shape. So we're just going to eliminate this contact right there. We're not even going to put that back in there. All right. So now, bearings seem good. Alright, pull that bolt. Pull that bolt. And that magnet is strong. Alright, so now we've got that pulled apart. But before I do this, I think I'm going to mark. I don't know if it matters, because I don't know if these magnets are the same distance from the end. It might not matter which way it goes. So let's just test that out. Nope. So this end here is the end that I got to slide it into. So we're going to put a mark there. Where's all my fucking punches? Alright, so we'll just have to note also that the leading end is the shorter side, because this is shorter from here. Alright, so now we've got that off. It just popped out. So now we need to size this to the other motor. The reason we need a certain width is so that it will go up inside of here, because the original motor will go up in there, and there's not much play side to side, maybe a 1/8. So that's why it matters that this is the right size. So I'm going to try to figure out how to chuck this up in the lathe and turn that down to the same size as the original motor. All right. Now we have it cleaned up, chamfered, and ready to put back on the motor. So now we got to make a plate that matches this. So I'll get that cut out in the bandsaw and probably start off with a hex. We got those holes. Now we're going to make them square. All right, guys. So now I'm going to show you how I'm going to make these square holes. So what I've got is a carriage bolt that's got the same size shank as what's on the motor. And that slides right down in there. And we're just going to drive that thing home with a big hammer. So all right, guys, my battery went dead. Well, then I went and got another battery, put it in there, and then I went to record again, and the damn SD card was full, so it wouldn't record anymore. So basically, we got the plate done, and I think what I'm going to do is I think I'm going to 3D print me a plate to go in between it. I don't think it would hurt too much to have a 3D printed plate, and I'll make it where it's got standoffs every so often, every fourth. So I think that's what I'm going to do, is just make that a 3D printed spacer to put in there to bring that out to where this here is level with this right here. That's going to make me measuring for the gear that much easier. So anyway, our goal is to turn this plate to have the bolt pattern for this motor, same as this motor here that came off of it. So we'll thread those in the next video. I may have it done by the time I do the next video, I don't know. I need to get this mill back up and running. I can always run that on the box just a little bit while I'm using the mill. So hopefully if I can get the motor to mount to it, then all I have to do is just mount the motor, put it all back together, I can use it, and then I can make all my other parts. Most of it's going to be electronics anyway. So anyway, hope you guys got something out of this, enjoyed the lathe work and the drill press work, milling on the drill press, which is scary. I don't like doing it, but you got to run it slow. I tried to run it fast, and then when I had to countersink it some more, I ran it real slow, so it cut really good when I ran it slow. So anyway, hope you guys enjoyed it. You guys have a good one. Later.